Okay, so today we're going to talk about linear inequalities, and our goal today is to learn how to graph linear inequalities. So these are inequalities that have a border line that's a line. So they have borders that are lines. And our vocabulary is linear and inequality. So the first thing I want to do is I want to review one-dimensional inequalities, because we're going to use the concepts of one-dimensional inequalities to extend into a two-dimensional system. Okay, so at the beginning of the year, we talked about these one-dimensional inequalities like x is greater than 3. So everything that would fit here are all the x values that are strictly greater than 3. So things like 3.01 would work, 3.1, 4, 5, 10, 1,000, those would all work. So when you have a one-dimensional inequality, the way that you show the solution, because there's an infinite amount of solutions to this one-dimensional inequality, the way that you show them geometrically is you draw a one-dimensional system, which is just a number line, and you put the number in the middle and you put some numbers on the side. Okay, and if x is greater than 3, so it can't be equal to 3, we put an open circle at 3 and we shade to the right. Okay, so the number line itself is split up into two parts. The parts that are a solution to the inequality and the parts that are not a solution. So these are solutions. And in the purple here, everything that's in purple, that's the other half of the number line. In the purple, this is not a solution. Okay, so likewise, if you have x is less than or equal to 3, you'd have a number line, you'd have 3 in the middle, you'd have some numbers on the side here, and x is less than or equal to, so if it's equal to, we shade that, okay? We shade because it is a solution, okay? And we work our way to the left here because everything that's shaded is a solution to the inequality above. Okay, so again, the number line is split into two parts, the things that are solutions and the things that are not solutions. And the same thing is going to happen when we jump into a two-dimensional system. We have, in a two-dimensional system, we have essentially two number lines that are perpendicular to each other, the x and the y axes, and our inequalities are going to split the system into two parts. Okay, so sometimes we're going to have shaded lines on borders, and sometimes we're going to have dashed lines on borders, and sometimes they're going to be solid lines. But they're going to have these two parts, this part right here, and the other part right here. And these parts are called half planes. Okay, because the whole two-dimensional system is called a coordinate plane. A plane is a two-dimensional object. Okay, so our inequalities that we're going to look at in the two-dimensional system there's going to be a border line right here, just like there was a border here. Okay, it's equivalent, and it's going to split our system into two parts that are solutions and parts that are not solutions. Okay, so let's look at a simple one. Oh, and by the way, this is called first-degree inequalities in two variables. First degree because all exponents are 1. All exponents on variables are 1. Okay, so they make lines. All right, and two variables because it's two-dimensional. Okay, so sometimes we have two variables. Sometimes even if we have one, we're still going to graph that on an XY and on a two-dimensional system. Okay, so let's talk about the easiest one. And I put a table here, but a table doesn't help us in this situation. I am looking for all coordinate pairs where the y coordinate's greater than 4. Okay, so there's an infinite amount of these pairs. Okay, and I'm going to shade the coordinate pairs so everything's certainly up here, because all these points right up here are the y value is 10. So at all these points right here and all the points in between. So there's a whole region where this is happening. So what we're going to do, the border of this is the line y is equal to 4. This is a border. Okay, it's going to split into half planes. So because y is not allowed to be equal to 4, I'm going to make a dashed line at the line y is equal to 4. Okay. Now a dashed line means that dash means not a solution. Okay, but everything above this is a solution. So I'm going to, okay, so shaded means is a solution. All right, and so this is the solution to my inequality. Everything that's shaded up here, and I'm going to write y is greater than 4 up here. Okay, now likewise, if I go to y is greater than or equal to 4, now I have this equals. So my border is still the line y is equal to 4, so I'm going to draw that line. Now I made it a solid line because y is greater than or equal to 4. Okay, so here I'm still going to shade above, right here, because these are all the points that where the y coordinates are greater than 4, but I can include that line right there. So this is the inequality, y is greater than or equal to 4. Okay. So if you have a less than or greater than, this means dashed line. If you have a less than or greater than, it means a solid line. Okay, like that. Okay, so let's try another one. X is less than negative 2. So I'm going to go to negative 2. I'm going to put a dashed line here because it's less than. And then I'm going to shade all the coordinates where the y coordinate is less than negative 2. Okay, and so I'm going to put y is less than negative 2 here. Okay, for the next one, this is going to be a diagonal line. And we want to think of this, the border line is really, you want to think of this as this line right here. That's the y-intercept, that's the slope, so I want to graph that line. So here is the y-intercept, and the slope is down to over right 1, down to right 1, or up to left 1. Okay, so here's the line right here. Okay, that's the border line, and it's solid because it's it can be equal to. Now I don't know which to shade. Do I shade here or do I shade here? Okay, so I'm going to make a test case. All right, my test case, I'm just going to pick one of the coordinates in one of the planes, one of the half planes. So let me pick this one. This one has a coordinate of 1, 2, 3, 3. Okay, and I'm going to put these in for the inequality. And I'm going to find out if it's equal to, or if it's true. So this ends up being not true, so I don't shade this side. Okay, so what I end up doing is I shade the other side. Oops. Okay, I'll just do it in solid. Okay, so everything in here is a solution. Everything in here and the other half plane is not a solution. Okay, and everything on the border, so one of these points on the border here, because it's a solid line, means all the border points are solutions. So border points are also solutions. For example, if I pick this point, so it's 0, 1, 2, 3, 4, 0, 4. If I put that in 4 less than or equal to -2 times 0 plus 4, 4 is less than or equal to 4. That's fine. So all these points on the line itself are also solutions. Okay. Now we have a line that's not in slope-intercept form. So the border line is going to be y plus x is equal to 8. So I'm going to proceed to put it into slope-intercept form. And I'm going to keep that, I'm going to put that coefficient as -1. So it crosses at 8 and it goes down and over. Okay, and actually it's supposed to be, it's solid. So that's actually correct. So it's a solid line because it's allowed to be equal to. That little thing tells you that. Now, which side do I shade? So I'm going to pick a test case. I'll pick the origin as a test case. So what I'm going to do is I'm going to go ahead and put the origin's coordinates into my, oops, that should be my x, and this should be my y. So I have 0 plus 0 is greater than or equal to 8. Is that true? 0 greater than or equal to 8. Not true. So that side right there is not a solution. So this side, not a solution. Okay, so that's a solution. All right, now you don't have to write not a solution. You just end up shading the side that is a solution. And so you want to write y plus x is equal to 8 here. Okay, it's actually probably better to write it. Y plus x is greater than or equal to 8 right here. So don't write this, but I'm just writing it to let you know that that side's not a solution. Okay, the next one here is negative y plus x is greater than or equal to -3. So the border is, so I'm going to proceed to put it into xy form here. Okay, so x plus 3 is here, and then it has a slope of 1. So and it's solid. And I'm going to pick a test case, okay, to see which side is shaded. So -0 plus 0 is less than or equal to -3. 0 plus 0 is less than or equal to -3. 0 is greater, sorry, that's greater than or equal to -3. Is this true? This is true. So we shade on the side where the origin is. Okay. And that is the end. I think I've done all of them. That's the end of our lesson today. So what you learned today was how to graph linear inequalities. So ones that look like lines like this. You could also have had one that looks like, let's say, x is greater than 3 in a two-dimensional system would look like a horizontal line, or sorry, a vertical line, and shading to the, whoops, as opposed to in a one-dimensional system, you'd have an open circle at 3 and shade to the right. So this is the difference between a two-dimensional and a one-dimensional system. And tomorrow we're going to talk about shading systems of inequalities and finding solution sets to that. Okay?